Good morning. In the previous classes, we have discussed some concepts regarding rational numbers. That is, we have seen what a rational number is. Then we have seen how to do arithmetic operations on rational numbers. Then we have compared rational numbers. Then we have converted rational numbers into decimal expansions, and we have converted decimal expansions into rational numbers. This is what we have done, and we have also learned some methods to find out rational numbers between rational numbers. That is, given two rational numbers, how to find out the rational numbers between those two given rational numbers. Then we have also discussed about representing rational numbers on a number line. So this is all what we have done in the previous classes. Some concepts which you have already learnt in your 8th class, and which I have recollected till now, or till this class. So we have recollected whatever you have learnt in your class 8. Now here we will be moving on to something new today, using rational numbers, and also we will see whether rational numbers are all the numbers we have, or are there some more numbers apart from rational numbers. So that is what we see, whether there is an existence of numbers other than rational numbers. So before I get into that, let me talk something about the straight line. Now you know what is a straight line. Straight line is a collection of points. Suppose this is your line. Now basically this is a collection of points. Then how many points you have? Now that is the question. How many points this straight line contains? Now in fact this straight line contains infinitely many points. Infinitely in the sense I use the word infinitely whenever you are not able to count them. That is, say you cannot count how many points you have got on this straight line. Therefore I will say that this straight line contains infinitely many points. That is what I use. Wherever I have the term to be used like uncountable, I will use the word infinite. In other words, here in this case I will say that this straight line has got infinitely many points. Now going about this straight line, as we have discussed that this straight line has got infinitely many points. Now I will choose some points on the straight line. Let us say this is the point which I am choosing, and this is one more point which I am choosing. Now I will assign a number to this point and a number to this point. So before I assign these numbers, let me also discuss about what it gives us. Now whenever you choose a point, or whenever you choose 2 points on a straight line, now that will give you a part of a line, which we call it as line segment. Now again, for this line segment, how many points do we have? Can you count that? Of course not. Therefore we say that this line segment contains infinitely many points again. Now let me assign a number to this point, say some 0, and say 1 to that point. I repeat it again. I have taken a straight line. As we have discussed, that straight line contains infinitely many points. Out of those infinitely many points, I am choosing 2 points. Say this is 1 point, this is another point, and now I am assigning a number to each of these points. So for this point I am assigning 0, and for this point I am assigning 1. 0 and 1 both are rational numbers, which we have already discussed in greater detail about those numbers. Now we have also discussed how to find a rational number between given two rational numbers using mean method. So I will also do the same to find out a rational number between these two rational numbers. So this is the way we go about using mean method to find the rational number between given two rational numbers. So these are your given two rational numbers. So 0 plus 1 by 2, this is the way we find the rational number between given two rational numbers. So 0 plus 1 is 1, 1 by 2. Now 0, 1 and 1 by 2 is a rational number between 0 and 1. Now it is clear that 1 by 2 will lie exactly between 0 and 1. Therefore I will choose the midpoint of this line segment. Say this is the midpoint of the line segment, and I will assign this midpoint to be 1 by 2. The reason I am taking the midpoint is 1 by 2 lies in the middle of that line segment. So I am choosing a middle point of the many points that this line segment contains, and I am assigning 1 by 2 to that middle point. So this is what I have done. Now when I have assigned 1 by 2, or when I have chosen the middle point here, again I have got a line segment with these 2 points. Again I have one more line segment with these 2 points. So again, may I repeat the same process? So consider this line segment. Now these two are rational numbers. Identify the rational numbers between these two rational numbers. Again, use the mean method. 0 plus 1 by 2 by 2. Simplify this, you will arrive at 1 by 4. So 1 by 4 again lies between 0 and 1 by 2, exactly in the middle. So I am choosing the middle point of these 2 points. So this is the middle point. Let us assign that middle point to be 1 by 4. Because 1 by 4 lies in the simple reason is 1 by 4 lies in the middle of 0 and 1 by 2. So I am choosing a middle point of 0 and 1 by 2. So that is what is. Similar case. Again, by mean method you can find the value and take out the middle point of this line segment and assign that value. And while you go across the mean method, again you will arrive at 3 by 4. Now I will repeat the process. Here, in the previous case, we have arrived at 2 line segments. Now how many line segments do we have arrived at? This is 1 line segment, 1 line segment, 1 line segment. How many? 1, 2, 3, 4 altogether. So again, for this line segment, you can find a rational number which is in the middle, and again a rational number in the middle, rational number in the middle, rational number in the middle. Again, this is a line segment. Again, you can find a rational number. This is a line segment. You can find a rational number. Likewise, you can assign again the middle points to a rational number. Similarly, again, this is a line segment. You will have a rational number. You assign to the middle point. Similar case. Assign the rational numbers to the middle points. So again, this is again a line segment. These are 2 rational numbers. Again, you find the rational number between rational number using the mean method. So that will be the middle point of this. Again, we will assign that number to the middle point of it. So likewise, when we extend this process beyond this one, you can also suppose say we have extended this. So we have gone with 2. Again, proceeding with the same argument, we will have all the points to be assigned to a rational number. Yes, that is what we can do. Let me revert back to this again. 0, 1. This is what I have done. I have taken a straight line. Then I have chosen 2 points on it. I have assigned 0 and 1 to those 2 points. Then I have calculated the rational number which is between these 2 rational numbers, which is 1 by 2. Since 1 by 2 is the middle of those 2 exactly, I am assigning the middle point of 0 and 1 to 1 by 2. Like the same, you have this line segment. Again, 1 by 4 is the middle of it. So that is the reason I am assigning the middle point to 1 by 4, and I am continuing this process. Now when I am continuing this process, I am coming to a conclusion that 0 and 1, in between 0 and 1, as we have discussed, there are infinitely many points. I can say that each of these infinitely many points are being assigned to a rational number. That is, given a point between 1 and in between 0 and 1, we can see that each of the points are being assigned a rational number. Like the same, if you go about with 1 and 2, we can apply the same argument here. That means between 1 and 2 you have infinitely many points. On the same argument, you can assign each point to each rational number. You can also go in this direction, and you can assign each point to a rational number. Likewise, this leads us to a probable conclusion that on a straight line, each point can be assigned to a rational number. So that is the conclusion that we can make. I repeat it again. By this argument, we can say that each point on the number line can be assigned to a rational number. There are infinitely many points, and each of these points can be assigned to infinitely many rational numbers. So the first observation that we can make is there are infinitely many rational numbers, because between any 2 given points there are infinitely many points. Therefore, we say that there are infinitely many rational numbers that you can assign to each of these points. Now we will check whether our argument is correct or not, or whether the conclusion that we made, that is, on a number line or on a line there are infinitely many points, and each of these infinitely many points can be assigned rational numbers. So that is the statement which I am making. That is, for each of the points on the number line we can assign a rational number. So that is the statement which I am making, and we'll see whether the statement which I have made is true or false. For the time being, I'll suspend the discussion of this and we'll move on to something different.